So we've looked at the skill of calculating when curves are increasing and decreasing and how the derivative comes into play for this. What I'm going to do in this video, I'm going to set you a couple of questions based on this. What I want you to do is have a ping at them, come back and then check your solutions against the working that will follow this. So here they are. So first thing I want to do is find the intervals in which the following two functions are increasing and then decreasing. So the first function is 6x minus 2x cubed. Second one is x cubed minus x. Second question, I want to show the function y equals x cubed over 6 is never decreasing. And the third one, show the function y equals x squared plus 2x minus 3 is increasing for all values of x except x equal to 0, which comes in from the divide by x. So, pause the video, have a crack at those, come back and get your working and your answers. So here you go. First question, find the intervals which these two functions are increasing and decreasing. So again, remember, to get whether the functions are increasing or decreasing, we need the derivative. So first thing we do for this one, find the derivative, f dashed of x. So f dashed of x here is 6, because it's a 6x, the x just goes, take away 2 times, and then you bring the power down, reduce it by 1. So that's 6, take away 6x squared. Now, this is when we start to factorise it, so we can play about with it. Take out a common factor of 6, we get 1 minus x squared, which then factorises to 6 bracket 1 minus x, 1 plus x. This there difference of two squares. Now, I want to find parts where A it's increasing and B it's decreasing. So for A, with it increasing, we want, and again we can ignore the 6 because it's always positive, 1 minus x, 1 plus x, bigger than 0. So again, it's the same sort of thought as last time. Either both of these are positive or both of these are negative. It's the only way you can get a positive value through a product. So we then know that 1 minus x is bigger than 0 at the same time as 1 plus x is bigger than 0, or 1 minus x is negative at the same time as 1 plus x is negative. So this first one here tells you that x is less than 1, or that x is bigger than negative 1. Second one here tells you that x is bigger than 1. At the same time, x has to be less than negative 1. So, you can just kind of write off this second set of values here, because if you can give me a value of x that's bigger than 1 but less than negative 1 at the same time, I think you'd be a miracle worker. So we can just ignore those two, and then that gives us our value range there. Because x is less than 1 but bigger than negative 1, so we know that if negative 1 is less than x, which is less than 1, we know it's always going to be increasing. Which means the values out with that are going to be for decreasing. So we know then that if x is less than negative 1, or x is bigger than 1, it's going to be decreasing. So there you go. We've determined where it's increasing, where it's decreasing. Second one is the same logic. First thing we do is get the derivative, then we look at that. So, take the derivative of that, dy by dx. I'll bring the power down, we get 3x squared. It's then take away 1. So, that's what we've got there. We want to know when that's increasing and when that's decreasing. So what we're then able to say is, fine, we know for it to be increasing, so let's look at part A first, 3x squared minus 1 has to be bigger than 0. Rearrange it, we get 3x squared has to be bigger than 1. So x squared, divide it by 3 and then take the square root. X squared is bigger than 3. X is bigger than 1 over root 3, or less than negative 1 over root 3. Remember, if this happens here, and we take the square of this, we'll end up getting the same answer as well. So now if we take any value in either of these two ranges, so x bigger than 1 over root 3 or less than negative 1 over root 3, we're going to get a value that gives us this part of the function, 3x squared minus 1, being bigger than 0. So if we want an increasing function, that's where it has to be. If we want decreasing, we then know that 1 over root 3 has to be bigger than x, which has to be bigger than negative 1 over root 3. Has to fall into that category there somewhere for it to be a negative value. So think about it, if we chose x as 0, it would be 3 times 0 squared, so it's nothing, take away 1, well that would be negative. So it's decreasing at that point. So there's your increasing part, there's your decreasing range. We have to bear that in mind when we're working with these. The next question, show the function y equals x cubed over 6 is never decreasing. So if this is never decreasing, what we want to show is that our derivative is always bigger than 0. It's always going to be a positive value. So that's the logic to think about. If it's never decreasing, instantly think that. The first thing we need to do is take the derivative of that. We need to figure out dy by dx. So dy by dx equals, so we've got 1 over 6, it's then times, bring the power down, 3x, and then reduce it, squared. What that gives me is a half times x squared. Now think about this. X squared is some number squared. Any value of x squared is always, always, always bigger than 0. What we're then able to say is, therefore, dy by dx is bigger than 0. So it's never decreasing. Alright, it's never decreasing. The only exception is when it's equal to 0, but then it's not actually increasing or decreasing. It's stationary, it's not moving. So we can take that into account as well. It doesn't worry about that. But if we ever go to a negative value, it's still going to come out positive because we squared. Similarly, what we want to show is show the function here is increasing again for all values of x except x equal to 0. So we want to be able to do that. Now, again, x equal to 0, it's told us there's an exception. It's because of that on the bottom. You can't divide by 0, so they have to include that. We want to show it's increasing for all values of x. Again, instantly we need to think dy by dx is bigger than 0. So we need to sort this and get it in a form that we can calculate the derivative of. So first thing to do, split it into 3 separate fractions and simplify it. So we're able to say y equals x squared over x plus 2x over x take away 3 over x. Split it into 3 singular fractions, then you can simplify each of these one at a time. X squared divided by x just gives you x. 2x divided by x just gives you 2. And negative 3 over x, well that's fine, but we have to write it in a differentiable form, remember, so we have to bring this up and then look at the power. So that then becomes minus 3x to the negative 1. Now that we've got that, we can calculate our derivative. So we've got dy by dx equals, well, derivative of x is 1. Derivative of just a constant, nothing, so that vanishes. We've then got this next part, so minus 3 times, and then bring the power down, so negative 1 x, and then reduce the power by 1 to the negative 2. What we can then say is fine, so that means I've got 1, so it's going to be minus 3 times minus 1, plus 3 x to the negative 2. Simplify it a wee bit, you get 1 plus 3 over x squared, and I want to show that that's going to be bigger than 0. That's what I need to show at this point. Best way to do it, combine this all into one fraction. 1 can be written as x squared over x squared. Then we can combine it. So at that point we get x squared plus 3 over x squared has to be bigger than 0. Now, x squared on the bottom here, this is always going to be positive regardless of which value we pick. X squared is always going to be positive. And this one here on the top, x squared plus 3, regardless of which value of x we pick, even if it's the biggest negative number in the world, it's going to be a positive value, which means that when we add something onto it, it's going to be a positive value as well. So this, x squared plus 3 over x squared, is always going to be bigger than 0. So actually that statement there is true. What we can then say is, therefore, dy by dx is bigger than 0 for all values of x. Exactly what we want, but we have to make sure we state that at the end. We have to tell them what it is we've determined, what it is we've done, and the actual point of it. Just writing down a wee thing that says x squared plus 3 over x squared is bigger than 0 doesn't mean you've been able to interpret it right. So, bear these little tweaks in mind. Derivative bigger than 0, increasing, derivative less than 0, decreasing. Look at the different possibilities for when it's increasing and decreasing, and remember some of you even know your basic maths. 2 positive numbers, 2 negative numbers multiplied together give you a positive. Positive and a negative together give you a negative. Remember all of those things.